This is the second lesson dealing with 4.3. And what we're doing in this part of it, we're still dealing with the second derivative, but now we're looking for local extrema using the second derivative. The basic idea here is before we were just looking at, if we want to find maximums or minimums, we were only looking at the first derivative. For example, in this case, our first derivative would be where this is 0 and we have a sign change. Whereas today we'll be looking at how to use the second derivative for that. We're also going to be looking at the graphs of f prime, and f double prime, seeing how to go back and forth and analyze information about those to be able to learn something about the other graphs. So we're going to start with that, looking at the graphs. Now, if we read this carefully, it says we're looking at the graph of the derivative of the function here. So this would be f prime in this graph. So if we want to know when f is increasing, that's going to happen when f prime is positive. So anytime that we're above the axis here, so going from -4 to 1, and then after that, this is always negative. So the next thing, when is the graph concave up? Remember, for concave up, we want f double prime to be positive or greater than 0. So since this is the graph of f, what we're looking for is where f prime is going up. Okay, we think about f prime as a function, its derivative would be the second derivative. And so we would analyze this graph just like we were going from our first derivative from our original function to our first derivative. Where this is increasing, that's where our second derivative is positive. And so there's two places where that's happening. Now this isn't an exact graph, but I'm just going to kind of estimate. It looks like it's happening at about 0 and 3. This actually looks a little bit less than 0, but I don't want to use fractions here. I'm just going to say that I'm increasing, or I'm going to be, my f prime is increasing, so f double prime is positive from -2 to 0 and from 3 to 4. Now, at what x-coordinates does f have a local extrema? So we're looking for maximums or minimums here. And remember that we want to look, if we're looking at f prime, we want to know, first of all, maybe where those are zeros, but not so much where those are zeros, because here we're positive on either part. There's no sign change. What we're really looking for is the sign change here. So over on this whole interval, f prime is positive. Over on this side, it's negative. So we're getting a sign change here. This is one of our extrema. Now we're also going to have, and so that would be, since we're going up and then down, a maximum at x equals 1. Now also, since this is all increasing, we need to consider the endpoints as well. Since this is all increasing on this side, everything going up and then everything going down, this is also going to be a minimum and this is going to be a minimum. I'm not sure which one is more, but at those endpoints, we're going to have minimum values. Okay, then we want to look for the inflection points. Remember, the inflection points were where we have a change where f double prime is equal to 0. So if f double prime is equal to 0, we need to think about this graph here when its derivative is going to change. So we look here, I'm going down and then I'm going to go up. Okay, so that means that for my second derivative is going to be equal to 0. Here I'm positive. I've got a maximum here. Yeah, so we're increasing and then we're decreasing. Again, I'm just kind of rounding this to 0. It looks like it's a little bit less than that. But again, my f double prime is going to be equal to 0 because this is the derivative of the first derivative. And then I'm going to get another one over here at 3. So at those points, x equals -2, x equals 0, and x equals 3, these are all zeros for f double prime because they're tangents of the first derivative. There's also for sure a sign change, negative to positive, positive to negative, and negative to positive, so I know those are inflection points. Okay, now the last part, I want to sketch a possible graph on this interval, and so I can use a few things about that. Since my f double prime is negative, that means I'm concave down on this interval, and then we are positive, so I'm concave up, then we are negative here, which means we're concave down, and then over here we're going to be curving back up again. We also want to look at f prime. Remember we said that from this point to this point, we were all positive, so we're increasing, and then from this point, actually I'm sorry, from to 1 here, that's where we're increasing, and then to 4, so negative 4 to 1, and then to 4, these are all decreasing. Now we don't know our starting point here. They didn't give that to us. So we can kind of start wherever we want to. We're going to be increasing, so I guess I'll start here. But even though I'm increasing, and I'm going to increase, I'm going to negative 2, I'm increasing, but I am concave down. That means that I've got to be curving down somehow on that thing. I'm also noticed that my slope becomes 0 here, looking at my first derivative, so this should kind of level out here. But then I'm still increasing. What changes there is now I'm concave up by considering the second derivative. And I'm concave up all the way until about 0 here. Remember, we just are rounding it because it's not very exact. And then I'm concave down again, but I am still increasing up until I get to 1. So here at 1, notice that my slope is 0, so this should level out. And now I'm starting to decrease. At 3, something else is going to happen. I have another inflection point here. Okay, I'm still concave down right now. But then at this point, after 3, even though I'm still decreasing, I'm now curving up. Okay, so this should be an inflection point right here. I'm curving down, and then I'm curving up, and then we end at 4. So again, what we were looking for here, we just chose a random starting point because we didn't have enough information. And then we know that we are concave down and then concave up, inflection point, concave down, inflection point. Okay, so where are our inflection points? Negative 2, 0, and 3. We also looked at increasing or decreasing, which was right here. We were increasing from negative 4 to 1, and then decreasing from 1 to 4. And so that's how we can get our graph from that.